Assalamualaikum and hello everyone. In this video, we are going to talk about our turbine blade project, starting from safety equipment and techniques, manufacturing steps process, problems that we face, and discussing on any improvements that can be made in the future. Before we start, let me introduce you to our members. First, Muhammad Haziq bin Ashni. His ID is 2023624738. Next is me, Nurina Shahran binti Shahrul Nizam. My ID is 2023888822. And Zaim Yafi bin Zamri. His ID is 2023668322. This is how distribution works among members. Introduction. Turbine blades are crucial components in turbines, devices that converts the energy of a fluid into rotational mechanical energy. In this project, the fabrication of a turbine blade is done using the appropriate materials, manufacturing processes, and safety techniques.
Safety equipments. Safety is the main priority before starting any manufacturing work. It is crucial and very important to avoid any injuries to the body. Firstly, safety jacket. It is to protect the body from minor cuts when doing work. Second, safety goggles. To protect the eyes from flying debris when cutting the workpiece. Thirdly, safety shoes. Protect the feet from heavy and sharp objects falling on the feet. Fourth, welding shield. For welding process to protect the eyes from the strong UV and infrared rays. Fifth, gloves to protect the hand for any injuries that involve the hand getting close to the machine. And then lastly, welding apron to protect the body from sparks and spatter when welding. Now let's talk about safety techniques. First, when accidents happen, quickly tell the lecturers or the staff to avoid any serious injuries. Second, use the emergency button on the machine to immediately shutting it down. Thirdly, use the shield on the lathe machine to avoid the metal debris getting into the eyes. And then lastly, always follow the safety guidelines to avoid accidents.
Now, I'm going to talk about manufacturing step we did on making the turbine blade. This is the worksheet that was provided. First, for workpiece are given a cylinder 1 and given square ones. 2. Measurements are marked onto the workpiece according to the worksheet given. 3. One of the square workpiece is being sawed with a hand saw into 3 different parts in order to make the blade. If the blade dimension is off, use a grinder if necessary. The cylinder workpiece is being cut using the lathe machine with the appropriate measurement. 4. The holes that are marked are cut into the 2 square workpiece. This is for the insertion of the cylinder workpiece and 3 screws. 5. The blades that had been sawed are brought into the milling workshop. 6. Cut the measure dimension on the third blade using the appropriate cutter. 7. Once the blades are done, thread one of the other square workpiece. 8. Continue milling that path away on both of the square workpiece. 9. Cut a hole through one square workpiece to mark it as the bottom part. 10. Once all the parts are done, assemble the parts together. 11. Drill a countersunk head shape in the top part for the screw. 12. Once everything is assembled accordingly, weld the bottom part to avoid the workpiece from falling apart. Lastly, finishing is done to remove an uneven parts that are being caused by welding. So, the turbine blade is done.
Now, let's proceed with the problems appears in our project. When the project is being manufactured, our team faced a lot of problems regarding our turbine blade project. Well, first of all, our milling cutting piece was broken. This is due to inconsistent speed and moving the cutter the same direction as the workpiece, causing it to break. To overcome this problem, we bought a new cutting piece as soon as it broke. Next, when we tried to assemble our workpiece, it did not fit properly. This is because the dimensions of the top part is not the same as the bottom part. We overcome this problem by making one of the paths bigger to make sure all of the parts are connected properly. Third, one of our screws did not fit into its assigned spot, the reason by the previous mistakes we had. However, we managed to solve this problem by forcing the screw in using a hammer. Fourth, the cylinder middle part was too long. This is caused by the error in dimension. We overcome this by cutting the workpiece more to shorten up the dimension. And then lastly, the workshop machine is always full. This caused our team to be behind schedule multiple times. However, in the end, we managed to finish the turbine blade on time.
Lastly, I'm going to talk about the discussion about the improvements that can be made into a more well-organized manner and produce a much more accurate result. Firstly, mark the workpiece dimensions with a thin permanent marker to obtain a much more accurate result when cutting it. Secondly, when cutting the workpiece using tools like handsaw, milling and turning, always cut a couple of millimeters more to avoid accidentally cutting less than the actual dimensions needed. Third, plan a much more organized schedule to be able to finish the turbine blade before the deadline so that when any problems that happen, it can still be fixed without the pressure of a last-minute urgency. Lastly, always coat the workpiece with oil to prevent the workpiece from rust and corrosion. Well, that concludes the end of this video. We hope you enjoy this and can take a lesson out of it. Bye and thanks for watching. Sincerely, Group 4.